Hey y'all, in this video lesson, I'm going to teach you about the transformations on the graphs of sine and cosine. Before we get into that, I want to first go over an easier example of something that you might have seen before in algebra. And to do that, I want to talk about this memory device that I like to use. I call it HIVO. I did not invent it, someone else did, but I like to use it. So HIVO is just a memory device for horizontal movement happens inside the parentheses oppositely, and vertical movement happens outside the parentheses. Okay, so that's kind of a lot of words. So you could shorten that to horizontal inside, vertical outside. That's much shorter, but I made it a little bit longer because the horizontal movement inside the parentheses is opposite of what you think. And this comes from the standard equations basically have minus already in it. And so minus is just part of the formula basically, and then that number is where it moves. So for example, if you have x minus 4, then the function is moving positive 4 units, so 4 units to the right. So even though you see a minus 4, it's actually just that nice little 4. And then if you have x plus 4, what's happening is x minus negative 4, and the movement is actually negative 4. So it's opposite of the sign that you see natively. So when you see minus 4, you think, oh, I'm going left 4, but it's actually right 4. So keep that in mind as we move forward. And that's why I put that in the memory device. The vertical movement outside, it's as you see it. If it's a plus 4, it's a plus 4. It's a minus 4, it's minus 4. So already kind of spoiled the one below a little bit. Didn't realize that. But I have an example. This is a quadratic. And we have g of x equals x minus 4 squared. That squared means it's a quadratic, plus 3. If we know what x squared looks like, which we do, the parent function of x squared is just a u-shaped graph, then we can translate that, we can transform that function by using this new function and knowing that horizontally this function moves to the right 4 and then up 3. So we can take specific reference points like 0, 0. This is my parent function. And I can go to the right 4, 1, 2, 3, 4, up 3, 1, 2, 3. And that new reference point is here. And you can do that with like 3 points and you have your new function. So instead of creating an entirely new table of values for the new function, we can just take what we already know and shift it over and up. That's it. So we're going to use that same idea for sine and cosine. We have this first example here. F of x is 1 plus sine of x minus pi over 4. And then down below, I have the parent function already graphed. So in your homework, you probably, or the assignments you're working on, you probably won't already have the parent function there, but it can really help if you go ahead and just draw that. And then that way you don't have to read, like I said earlier, redo an entire table of values. So all I have to do is look at this transformation and go, okay, horizontal movement is inside. So I have horizontal movement of pi over 4. That means I'm going to go right pi over 4. And then I have vertical movement outside of a positive 1. So that means I'm going to go up 1. And it's easiest, like I said earlier, to take some reference points, some anchor points, and move those. So very simply, I have 0, 0 right here. It would be very simple to move 0, 0. And I have written down below the graph that these increments are in pi over 4, and I will show you how to do that in the calculator in just a few minutes, but for now, don't worry about that. But the increments are pi over 4. I set it in my calculator to do that. So I'm going to go right pi over, sorry, I need to expand on that. The x values are pi over 4. The y values are 1. I believe. Yeah, 1. Okay, because that's pi over 2, 1. Okay. Y values are by ones. Sorry about that. All right, so now I can go to moving. 0, 0 is going to move right pi over 4 up 1. So my new point is here. And then this point is another easy one to do. I'm going to go right pi over 4 up 1. So my new point, a little off. I can get closer. Pi over 4 up 1. And then you just keep doing that until you have enough points that you can sketch the new graph. So go ahead and try it. So yours should look something like this. I did lots of points just to get that better idea. You could probably get away with 3 or 4 points and be fine. But I went ahead and just did each of these critical or reference points there, moved them right pi over 4, up 1, and there's the sketch of the graph. So now we can do the same thing with cosine. I've got the parent function already graphed. And then I want you to figure out how it's shifting, left or right, up or down. Go ahead and draw it. And so pause it, try it, come back and check your work. So my sketch is a little bit rough, but it's correct. So we're going to go left 3 pi over 2 since it's plus 3 pi over 2. And we're going to go down 1 because of the -1 outside. I did state at the bottom that the x increments are pi over 2. So I took some reference points. I did have to like mark them that I had used them because I was getting a little lost in them. I put a little X on them, and then I went back and erased those. So this one, we go left 3 pi over 2. That's 1 pi over 2, 2 pi over 2, 3 pi over 2, down 1. So that's the new point. Then I did that for this one. I go left 3 pi over 2. That's 1 pi over 2, 2 pi over 2, 3 pi over 2, down 1. So that's another point. And then you just do that for as many points as you need. Draw that sketch. You can see I only did 1, 2, 3, 4, 5 points. And then I just kind of continued the rest since it's just a sketch. And that's what it looks like. And also, I mentioned that I would show you in the calculator how to set this. I mentioned that my increments were pi over 2 or pi over 4. You can do that in your calculator if you want to just do a quick check. Make sure first that you're in radian mode. Then you can go to your window, and I can pull that up for you. You can go to your window. That is second graph. And you can type in what you want your window to be. So typically -2 pi to 2 pi on the x-axis is plenty. So I did -2 pi, 2 pi. And then I wanted my x scales to go by, this one was for sine, pi over 4. And then I did a y minimum of -3 and a y maximum of 3. The reason why I did that is because I knew it was going to be shifting up 1. So where my original graph ended at 1, my new graph would need to go up to 2. So I just went a little bit past that so that I could see the full picture of what that looked like. And then I just did a y scale of 1. That's totally fine. And then you're gonna go to y equals. The original function was sine x. My new function was 1 plus sine of x, was it minus? Minus pi over 4. And then hit graph. And we can compare what we did by hand. And you can see that it is pretty similar. So the green one is the parent function and the red one is the shifted function. And you can check your work that way. And that's what it looks like. So pretty cool. Just make sure you're in radian mode since we're talking about radians. Okay, amplitude, period, and frequency. We're going to talk about what those words mean and look at a few examples of that. The amplitude of a wave is basically the measure of its height. So I talked about the parent function of sine only went up to 1, and then the new function went up to 2. Because that height is constantly changing, amplitude is defined as the farthest distance the wave gets from the center of the wave. So here, the parent function of sine, this is the center, and it has a height of 1. And that's the amplitude. So let's compare the amplitudes. Sorry, I need to put 1 right there. Let's compare the amplitudes of sine x and 2 sine x. Go ahead and try it. So far, I've just plotted sine x. And then for 2 sine x, if you're a little stuck, we can think about this logically. We're taking 2 and multiplying it by whatever we get for sine of x. So the y value of that, basically 2 times the y value. So sine of 0 is 0. So 2 times 0 is 0. I'm going to do a different color here. I'll do blue. And then sine of pi over 2 is 1. 2 times 1 is 2. So that goes up. 0 times 2 is 0. -1 times 2 is -2. And so on. You can do that for the whole graph. And then draw your little curve. So what do you notice? My blue curve's kind of rough. What do you notice about the height of the pink graph, sine x, and the height of the blue graph, 2 sine x, about the heights of those? The height of 2 sine x is 2. So it's 2 times the height of sine x. So 2 sine x has an altitude or height of 2, which makes sense because it's 2 times sine x. Now I want you to do the same thing for sine x and half of sine x. You probably could have guessed this one, but the height or the altitude is half. So for 1/2 sine x, the altitude is half of sine x. So it's just shrink down half because you're taking half of all the y values. And that's what that looks like. The period of a trig function is the horizontal distance traversed before the y values begin to repeat. So it's basically the length of one full wave. For both graphs, sine x and cosine x, the period is 2 pi. So it completes one full wave at 2 pi, and then it starts to repeat again. So if we look up here, at the pink graph, we've got one full wave. And that keeps repeating. So it completes one full wave in 2 pi. So the period of cosine and sine are both 2 pi. The frequency is very closely related to the period. Since periodic functions are based on the unit circle, we measure frequency as the number of complete waves every 2 pi units. So for sine and cosine, there is exactly one complete wave every 2 pi. So the frequency is 1. We have, this is sine 8x. And so we're trying to figure out for the frequency, how many waves exist in this region. And so you would go 1, 2, 3, 4, 5, 6, 7, 8. 8 waves exist in that space. So the frequency is 8. One period or a period would be one wave. So period is how quickly that one wave happens. So each wave is pi over 4, I believe is what it says. One wave, and so on. We have an example. What is the frequency and period of y equals sine of 5x? If we look at the graph of just sine x, and then we type in also the graph of sine 5x, let's just kind of compare those to see what's happening. Let me pull that up. And maybe, there we go. Done, clear. Sine x and sine 5x. I'm gonna graph it. And the green one is sine x, and then the red one is sine 5x. So you can see that I do have one little wave there. If you go from 0 to a little bit past 6, that's 2 pi. I have one full wave for sine x. And then for sine 5x, we've got 1, 2, 3, 4, 5 waves in the span of the original one wave. So sine 5x has 5 times the amount of waves within the 2 pi space. Multiplying the angle by 5 should result in the sine wave completing a cycle 5 times as often as sine of x. So there will be 5 complete waves between 0 and 2 pi. That means that the frequency is 5. And then if we're trying to figure out the period, then if there's 5 complete waves in a 2 pi space, then one wave will be 2 pi divided by 5. I skipped ahead. Sorry about that. That is a fifth. One period is a fifth. So that is 2 pi over 5. Just to kind of relate that from the one that we saw above, we had 8 waves in a 2 pi space. So if we do 2 pi over 8, that gives that period of pi over 4, where one wave was completed at pi over 4. So that relates down here just to follow that pattern. If there were 5 waves, then one of the waves, 1/5, one of the 5 waves is completed at 2 pi over 5. So that is, I didn't write that down, but this is the period. And the frequency was how many waves were there. So that was 5. All right, so for this example, I want you to identify the amplitude, period, and frequency. And pause it, try it, come back. I just also realized, so sorry, on the previous page, I called them altitudes. I think I meant amplitudes there. Altitude is height, so maybe I was talking about height. Anyway, sorry about that. Down here, the example we're on, the amplitude is 2. It's that number out front because we're doing 2 times the original cosine. The frequency is 3 because that's that number with x there on the inside. We're having 3 waves completed in a 2 pi period. And then that period is 2 pi divided by 3 because each wave, there's 1 out of the 3. So it's a third of, anyway, 2 pi. So amplitude 2, frequency 3, period 2 pi over 3. Okay, guys, for the sake of the notes, I do want to go back up. That bothers me. I'm sorry about that little typo. This is amplitude there. So if you have these notes, then just correct that. All right, moving on. We've got a picture of a graph, and we're going to identify the amplitude, period, and frequency of this graph. Pause it, try it, come back. For this one, or any one like this, it might help to figure out that where your center is or your midline. So I did a really bold blue line there. So that's the center. And then the amplitude is the height from the center. So from the center to the highest point on the graph, it goes up to 3. So amplitude is 3. And then frequency is the number of waves completed in a 2 pi period. There's several ways you can look at this. One of the ways is you can start here, because from here to here is very clearly 2 pi. So if you start here, then where that value repeats again is here. So we could consider that one full wave. So the period, one full wave, is at pi. And then you would go 1 full wave, 2 full waves. So the frequency is 2 because we complete 2 full waves in 2 pi. The other way that you can look at it is if you don't like that as a wave, you feel like that's not a full wave, you could start a little bit farther to the left, and then that's a little bit more like a wave, and then it would end here, and it's still 2. I just kind of shifted my 2 pi window to the left a little bit. So it's okay if you did that, as long as you get that there's 2 full waves in the 2 pi period or 2 pi window, then you got it. And then period, there's 2 ways you can do that. You can just see where 1 full wave ends, which was at pi, or you can do 2 pi over the frequency, which was 2, reduces to pi. So that's all. That's all for that problem. I want to summarize a few things down here that will help you as you navigate these problems. So if we have f of x is a times whatever the trig function is, sine or cosine, times b times x minus d plus c. So it's this, that looks really messy, but I'm going to show you an example, so don't freak out. But basically, I want to show you that that number out front is the amplitude or the height from the midline. The period is 2 pi over the frequency, which the frequency is that number multiplied by x. And then the frequency is that number multiplied by x, or in this case, the variable b. If you found the period first, then you can do 2 pi over period. And then the phase shift, it shifts horizontally d units. And then the midline or the center is the c value, which is also the vertical shift we learned with transformations. When you go up or down is outside, and when you go horizontally, that's inside. So horizontal movement, vertical movement, this is also the midline. So all the pieces dissected. This is a nice little summary. If you feel like that's going to help you, then you can go ahead and make note of that. So with that, we have this last example here, and we are going to state what this new graph will look like. So you're going to identify amplitude, period, frequency, maximum and minimum points, vertical shift, horizontal, all the things. So we're not going to actually draw it. We're just going to use the little summary up here and what we already know about these functions to draw some conclusions about this. So go ahead and pause it, try it, come back and check your work. So for this one, I did a little bit of labeling before I started answering the question. I knew that this was going to be a vertical shift since it's outside the parentheses. I knew this was going to be a horizontal shift since it's inside the parentheses. That frequency was going to be in front of my x, and the amplitude was going to be in front of my function. So I just labeled those, and then I went to work on the rest of the problem. So this is a sine wave that has been translated 1 unit to the right and 2 units up. And it's to the right because it's -1. Remember, it's opposite. And 2 units up because that 2 is on the outside of the parentheses. The amplitude is going to be that number in front of sine, which is 3. The frequency is 2, the number in front of x. The period of the graph is 2 pi over 2, which is just pi. So where that came from was the period is 2 pi over the frequency, which was 2. And so that reduces to pi. The function reaches a maximum point. Okay, this is something we haven't necessarily talked about, but if you know about each piece, then you can figure this out. The midline, the center, is at 2. And then the amplitude is 3. So if it goes 3 higher than that, then that puts us at a maximum point of 5. And then 3 lower than 2 puts us at a minimum point of -1. And that is all the pieces to the transformation on this function. So that's all I have for this lesson. I hope you enjoyed it. If you have any questions, please let me know. I'd be happy to help, and I'll see you in the next one.